guys, welcome back from the ad break. So we are still looking at exponential equations that we are trying to look at. Now we're gonna mainly look at some exponential equations that involve rational exponents. But let me show you what I'm talking about. So the main keywords here will be the rational exponent, because you need to know exactly what is a rational exponent. Now, when solving exponential equations, right, and they include addition and subtraction of several terms, the main thing is to always factorize in order to solve the equation. And you know your types of factorization here will be the common factor, and it will be the trinomial way of factorizing. But before that, I just want to go back to the concept of a rational exponent quickly so that you understand what we are talking about, right? So remember, from just defining number systems when we started doing our maths at an early age and all of that, they called a rational number as a number that can be written in the form of A over B. Similarly, with a rational exponent, it's the same thing. It's an exponent in the form of a fraction. That's it. It's nothing different or anything like that. The rational part of it still means a rational number, but it is a rational number that is an exponent at that time. So you really need to make sure that you do understand that. Now, when solving using the common factor, make sure that first your bases are the same. What do? You look at the exponents, right? And when you're looking at the exponents, the coefficients of the variable are the same in all the exponents. That's what a common factor means. So it means I have 3 to the exponent of x, right? Multiply by 2 maybe to the exponent of x, like that. So what this means is I am looking at the bases that are not necessarily the same, but my exponents are the same, right? But I can't take out a common factor here unless I then say plus 3 to the exponent of x. Then you can see that my bases here will therefore be equal. So that's really what I mean there. There will always be what we call a constant term that is present, meaning after taking out a common factor, there should definitely be a constant term. Now, when it's a quadratic trinomial, again, the goal basis must be the same. From there, you look at your exponents, right? What will happen with the exponents is the coefficient of the variable are not the same in all the exponents. What does that mean? It means that one exponent will be twice the other exponent, or it will be a negative of the other exponent. What do I mean? It will be maybe 2 to the exponent of 2x minus maybe 3 multiplied by 2 to the exponent of x, and then maybe also minus 4, like that. Because remember, it's a trinomial, so it's 3 terms, right? You can already see that my exponent here is 2 times that exponent there, right? 2x is twice x, and it's a trinomial. So that's the main thing that we need to look at. And why am I looking at this? I'm looking at this because the bases are the same of those exponents I am talking about, right? So that's what I mean when I say look at your exponents. And then always, you know, I'm gonna have a constant term because it's a trinomial, and a trinomial always ends with a constant term. But now let's put this into the actual practicality as to what exactly do we mean. The question, as always, it will be solve for x, and then to solve for x, you will need to look at what is it that you are given, right? So firstly, I will write this in standard form. In standard form, this is the same as 2 to the exponent of x multiplied by 2 minus 2 to the exponent of x minus 12 equal to 0, right? And as you can see here, you will then try to see if I can factorize this. Firstly, if these exponents, one is twice the other, then I can factorize. But look at them. Are they twice one another? No, they are equal. Therefore, what method must I use here? I use the method of a common factor, right? So I will then use the method of a common factor. So immediately that is the case, I will just erase this because I just wanted to show you how you then need to look at this. So this will be equals to the 12 will remain where it is. Why is it remaining there? Because the exponents are not the same. Are the same, I mean. One is not twice the other. If it was, then it will be a quadratic trinomial. Now on the left-hand side, this is squared there. I just forgot that 2. So if I take out a common factor, it will be 2 to the x into 2 squared minus 1. And this will be equals to 12, right? And then this will be 2 to the exponent of x into, in the brackets, I have 2 squared, that's 4, minus 1, that will be 3, and that's equals to 12. You divide both sides by 3. Let me use a different color just so that people can see the differences here. If you divide both sides by 3, I will have 2 to the exponent of x equals to 4. And then from here, you know, it will be 2 to the exponent of x equals to 2 squared. Bases are the same, 1 power, equate the exponents. So it's x is equals to 2. Then you can always just take that 2, substitute it back so that you can check your answer, right? So to do that, I will just write it on top, but I will work it out for you here. So if I write it there on top, 2 plus 2 will be 4. 2 to the exponent of 4, I know will be 16, minus. This one will be 2 squared, and 2 squared is 4. I minus that, and this will give me 12, which is the same as that answer there. So that will therefore mean that my answer is definitely correct. And then we look at this one here. This is going to, firstly, let's simplify everything. It's going to be 3 multiplied by 3 to the exponent of 2x minus 3 to the exponent of 2x times 3 to the exponent of minus 1 equals to 24. Why am I not changing the 24? Because you can see that I have this exponent and that exponent, and they are the same. So it means there's a common factor here. So it will be 3 to the exponent of 2x into 3 minus 3 to the exponent of minus 1 equal to 24. And then if you simplify the bracket there, it will be 1 over 3. And therefore, it's going to be 9 minus 1, which is 8. So this is going to be 3 to the exponent of 2x into 8 over 3. And it will be equals to 24, right? And then multiply both sides by 3 over 8 or divide by 8 over 3, however way you prefer to do it, right? So this will give me 3 to the exponent of 2x equals to. If I multiply the 24 by 3 over 8, the 8 there goes 3 times. If I multiply those two, they give me 9, right? So this will just be 9 there. But you can just use your calculator. You don't really need to do it using mental maths like I am. 3 to the exponent of 2x equals to 3 squared. Bases are the same, 1 power, equate the exponents. So it's 2x equals to 2, and then x equals to 1. And then you can always just test your answer whether it's correct or not. Now, let's look at this one now. With this one now, there's a different thing that is happening here, right? So let me quickly show you the first two that we did. My exponent was the same as the other exponent in terms of the variable. The exponent was the same as the other exponent. But now, if you look at this one, this will be 3 to the exponent of 2x minus 4 times 3 to the exponent of x times 3 plus 27 equal to 0. Already you can see that this is x and that is 2x. So one is twice the other. So as soon as one becomes twice the other, then we treat it as a quadratic trinomial, and then we try try to simplify it from there. But firstly, before you do that, remember, just like any other algebraic equation that you will have, if I have a common factor throughout, I can divide by that common factor, right, which is a number. At that point, it will be the highest common factor, and then only factorize after. So we look at that even here. So you can see that I have this 3 there. Maybe I can try divide by it, but if I do that, this will make it 2x minus 1. So I will just make it 3 to the exponent of x all squared minus the 12 times 3 to the exponent of x plus the 27 equal to 0. And then I said if you do not know what to do, you can say let 3 to the x equal to k. It means that if you let this to be equal to k, this will be k squared minus 12k plus 27. You can now factorize this, right? To factorize this, it will be 9 and 3. So this will be 3 to the exponent of x minus 9 into 3 to the exponent of x minus 3, right? Equal to 0. And therefore, this will be 3 to the exponent of x equals to 3 squared. Why 3 squared? Because 9 is the same as 3 squared. Or 3 to the exponent of x is equals to 3 to the exponent of 1, right? Then my final answer here will be x is equal to 2 or x is equal to 1. Then you can always go back, substitute, check whether your answer is correct or not. If it is not, then you leave it at that. So you then go back and recheck where you went wrong and all of that, because if it's not the same on either side, then there's something that you did not do right there. Guys, I know we've done a lot so far, but now I want you to just quickly take a walk around the house, try to drink some water, refresh a bit, look at your notes and try and make sense of what you are seeing, because after the break, we're then gonna do some more work.